this is merging and sorting data. So when you want to merge some data, so merging two lists together, so you have two lists of names that you want to merge. So two lists, so I'm just going to do it alphabetically instead. I'm not going to actually do real names, I'm just going to do it some letters. So the aim is to combine the two lists together whilst ensuring everything is in the correct order. This is merging. So two lists is A, B, F, H, Z. Then the list 2 is D, E, F, G, I. So then merge list would be in the order. So A, B, D, E, F, G, H, I, Z. The two lists, they contain all the letters from both lists, and as you saw, there was two Fs, so the two Fs are in there. Now then, so the process that this is to merge the two data items within the order into one, so two ordered list data files into one ordered data file. So first thing is that it compares the first two values from the list. It writes the lowest value in the new merged file, so it's called like file C or so. It deletes the lowest value from the old file. So then if one data file is empty, it writes the rest of the other data file to the new merged file, and then the process is finished. This is called iterative. Right then, so in order to get these things to order, there's the sorting. So an insertion sort works by splitting a list into two sections, a sorted one and an unsorted one. Elements from unsorted list are compared to the first item in the sorted list. If they are smaller, they are swapped, otherwise they remain in the same position. By repeating this process, the sorted list grows larger and the unsorted list shrinks, so it becomes smaller, until only the sorted list is left. Right, so using the insertion sort, we have to sort these numbers into the correct order. So there's 12, 31, 14, and 92. So the leftmost number is said to be sorted. It's by itself, so it does not need to be sorted. 12 is then compared to the next number, 31. If it is smaller than, it is swapped round, otherwise it is left the same way they are, so 12, 31, 14, 92. Now, then it moves on to the next number, which is 14, and it is compared this to the first number in the sorted list. So if it's smaller, then they are swapped round, otherwise it's left the same. So since 14 is larger, it just stays where it is, so it's 12, 31, 14, 92. Now as 14, then the next number, so 14 is compared with 31, and since 14 is smaller than 31, they are swapped, but 13 is larger than 12, so they stay the same, so 12, 14, 31, 92. Finally, the last item in the unsorted list, 92, is checked against the first item of the sorted list. If it is larger, it's larger, so they are not swapped, and they are sorted. So otherwise, if it's larger, it stay the same, and I think they do keep going back to like 92 to 14, 92 to 31, and then so on and so forth. So the final thing is 12. So the final thing is 12, 14, 31, 92. In insertion sort, it steps through the list, inserting each item into the correct position related to the sorted item before it. The insertion sort is simple to implement and generally quicker for small database sets than a quick sort. A quick sort, there's loads of steps. There are steps that it does. So there's 7 steps. So it picks a random element of the array to be the pivot. So an array can just be the list as well. So it picks the leftmost element of the array and the rightmost element, so the far left, then far right. If the item at the left of the array is less than the pivot, it stays where it is, and the next element along is selected. This step is repeated until the left pointer is pointing to an item that is greater than the pivot. If the item at the right of the array is greater than the pivot, it stays where it is and the next element along is selected. This step is repeated until the right pointer is pointing to an item which is less than the pivot, so it creates the two lists. Well, two sublists sort of thing. When the left pointer is holding a value greater than the pivot, and the rightmost pointer is holding a value less than the pivot, these two items are swapped. This process is repeated until the item has every item less than the pivot on the left of every item greater than the pivot on the right. So the pivot is just randomly picks a number, and then things that are less than that pivot, it is to the left, and then everything that is right to the pivot to the right. Now this is mirrored, so everything to the left, then everything to the right. So a quicksort now splits the list in half, so they have two separated lists. One contains all the values less than the pivot, the others contain all the values more than the pivot. Now steps 1 to 7 are now repeated for each of these sublists. They keep being repeated until each sublist contains just one element. Then lists are reassembled to give a list with all the items sorted. The quicksort selects an item at random, which is called pivot. It then creates two new lists, one with all the items less than the pivot and then one with all items greater than the pivot. This process is repeated until all the sublists have only one item. Now advantage and then disadvantage over the insertion and then quicksort. So insertion is very simple to implement and are quicker for small datasets, so that's the main advantage. Then quicksort is more complex to implement, so that is a disadvantage, but then it's much faster though for larger datasets. Now the next video is just the questions for data structures. Thanks for watching this video.